Thank you everyone for being here. I'm really excited to finally do a physical event. It has been 2 years of a lot of virtual and meeting people online, so it's really great to see people here. And as she said, I'm leaving to Germany, and it's really cool to do one last event before I move out to Singapore. And today, I just want to talk a little bit about what's new in Android, what is happening. And of course, that means Android 13. So as you know, every year we release new versions of Android where we do improvements, we do some changes. And this is the time of the year when Android 13 starts to come in beta. This time, this version is a bit earlier, and we already on beta 3 was released last week, and that reached the moment that it's platform stability. That means that the APIs will not change anymore, and you are safely to integrate into your code base and do the changes, and knowing that the final version of Android 13 will not change or break your implementation. So I'm going to cover quickly some of the new changes that introduced the Android 13. Of course, as you might have known, we have been iterating the last few years with privacy and security, but as well, power and performance are really a focus for us. So let's quickly take a look. Notification permission is a new change that we are adding, where we are creating a new permission that every app will have to ask for permission to show notification. We have received many feedback where users have a super cluttered notification tray. They don't know even how to remove the notifications or how to block applications to do that. So it's a change that I think will be really welcome for users and will help declutter your notifications tray. This change will affect of any application trying to push a notification, regardless if your code base targets Android 13, so it's the SDK code 13.3. On the case that you are not targeting 33, what happens is that the system will request for you the permission when the application starts. And if it's rejected by the user, then you will not have the ability to push the notification, but it will not crash. It will just simply silently not show the notification for the user. But of course, it's better if you adapt this change, so you can perform your own permission flow to request to the users. As any other Android permission, you have to declare it on your manifest, and then you have to adapt your flow. So you let the user know why you're requesting this and why they should give you permission to show notifications. We recommend, of course, to provide this information is rational, and as well allow the user to actually skip this part. If they really are not interested on your notifications, then let them skip and not requesting for the permission. Because maybe later on, after they use the application, you can ask again, and then they might be more prompt to accept it. But if you ask too early and they reject your permission several times, they get permanently denied. So then you will not be able to ask for a permission on the future. We as well made some other changes. This is more like for the users. It should not affect many of the applications. But there is a feature on Android where you can start a foreground service that requires to show a notification that your application is doing some sort of work. It can be a network uploading or like a microphone using or something like this. And this notification cannot be dismissed. So now on Android 13, this notification will be dismissible. So it does not clutter the user notification dashboard. What happens is that we have a new permission, we have this like dismissible foreground service. So it means that you can end up on a state where you have a foreground service that is not having notification, so the user is not aware that your application is running something. So that's why we introduced a new foreground service task manager that basically will kind of like keep the things tidy and make sure that if the foreground service was doing maybe a playback and you dismiss notifications, it will stop automatically. It will as well make sure that service is not running too long without the user knowing. So it might pop up a notification to the user saying, oh, actually there is a foreground service that was running and maybe you want to stop it. So that's another thing that users will be able to stop the Foreground service directly from the notification. Another privacy change that we're doing is introducing something called photo picker. This is a way for your application to request a user for a file, a photo, or a video without actually having to request the media permissions. And then the user can safely choose only the picture they want to share with your application without giving you access to the full pictures of their device. It is as well going to be backported to Android 12 and 11, and it will support much nicer UX and animations and so on. It will be more smooth integrated into the Android, so it will be better than if we implement this on your application. To use it is quite simple. You just need to use the Activity Result API and request for the big visual media. And once the user finishes with choosing a picture, you will get the URI, and then you can do whatever you need to do with that URI. Another change that we're doing that was already introduced on the past version of Android 12 is the privacy dashboard, where it shows which permissions are being used by the apps and when those permissions get accessed by those apps. This allows the user to know if there is an app that maybe is doing something wrong or accessing the permission when they don't want it. But now we're extending as well more like information around that to a 7 days. Together with that, we are bringing an API that can actually revoke by yourself the permission that the user granted. Why is that? So imagine you have a feature where you were requesting a camera, but then you remove the feature. Your application will still have the camera permission. This camera permission highlights on the privacy dashboard that your application has camera permission. So the user might be confused why that's happening, right? So with this API, you can revoke the permission whenever you remove a feature or whenever you don't need that permission anymore, and kind of be a good citizen and make sure that you are not having more information that you need on your app. All right, so now let's go again to an area where it's really important, and that is how applications run in the background. It's kind of a trade-off, right? So you have, for one side, developers who are really keen on having the application running all the time and doing a lot of things, but at the same time, you have some users where they have many apps, they use their phone daily, and you are consuming their battery. So the Android OS kind of falls in the middle and tries to be balancing the developer experience, but as well the user experience. So in the past, we have app restrictions, we have app limitations on how you can use the CPU on the background of the app. What happens as well is that the manufacturers as well, they implement their own optimizations. And sometimes then these are not really documented and can be a bit tricky to know how your application is going to behave on the background. This is why we try to standardize these app restrictions on the background. So basically, your application can be either unrestricted, so they will not be killed, you will have always CPU process, or it can be optimized, meaning that if the application is not being used, it's going to be killed. We'll try to optimize all the tasks we're doing. Or restricted, that means that the Android OS will not allow your application to run on the background. There is, with these optimizations, something called standby buckets. Those are buckets that your application is put into based on how frequently the user uses your application. And some of these buckets are having limitations. For example, if you're on the most restricted bucket, it means that your application only can run every 24 hours on the bucket, something like this. What happens is that sometimes there are things that you really need to be precise on the moment they are executed. This is why there are the high priority FCM that allows you to send a push notification from the cloud into your application, so your application wakes up and does certain things. Or, for example, ringing an alarm. That's something that the user doesn't want to wait 24 hours to get your alarm. So on Android 13, we are splitting these buckets where we'll put you into some restrictions with this type of really high priority notifications. So you make sure that if the user really needs this priority, you are able to do that. Let's go into security. So last year we started restricting as well some of the let's say it again. So we forced last year that any component on your application that you have it exported to other third parties, for example, a broadcast receiver or a service that anyone can access to your application via LinkedIn or something like this, it had to be declared if it's exported, so it can be accessed by other applications or not. But now under 13 as well, it's not only that in order for a third-party app to launch a service or to launch an activity on of your application, they need to specify a specific intent filter. If they don't do that, the OS will block that. What that means is that, for example, before any other application could launch an intent to your app and try to maybe inject some sort of data through the intents. But now, if you really want to block that, you will define an intent filter on your manifest, and you will not allow other apps to launch your activity, your service, or broadcast receiver. Similar to what I was saying, on Android 12, you're forced to declare if a broadcast receiver can be exported, means it's visible for other applications rather than yours. But you could not do that for runtime broadcast receiver. So now you have an API for that. Other stuff. So predictable back gesture is a new API that will change the way that we handle the back navigation of Android. This is a really important change in order to enable better transitions and be more predictable for users. Where is the app or the activity, like the UI, gonna go when they make the gesture to go back? With this API, you are letting them know in advance to the OS if you're going to handle that gesture or not. If you're not going to handle, the OS then knows what it's going to show. So it can do nicer animations, for example, rendering the previous UI. So it already kind of shows a little bit of the UI to the user when it starts to do a gesture. So the user knows where it's going to go on the map. So this is just the first API. And it's going to help on this, meaning that you don't have to handle the on-back tests, and you rather will go and use this pattern and all that. Right now is an opt-in behavior, so you can try this out on your applications by having this flag, but it's not going to be enabled by default when you're using Android 13 with your application. Another important change, especially for around the Asian region where there are so many languages, is the per app local preferences. So before, you can either change the locale of the full phone, so the language of the full phone, and that will change the language in which the applications are shown. But you could not say, I want this app to be in English, but I want this other app to be on my native language, for example, Spanish. Now, as a developer, you can implement your own custom language speakers, and with some dirty tricks, you can actually manage to change the language on your app specifically, but it has some issues. And with this API now, we are enabling system language speaker and a way for you to actually leverage the OS to do this for you instead. On the Android 12, we introduced a new material U, where kind of become like a better UI where the full OS are customized based on your wallpaper. So, for example, the widgets, they will turn in different colors, and what they call dynamic colors. And some of the icons, specifically the Google icons, as well turn into the color of the wallpaper. Now on Android 13, we are enabling these for any application. So you can provide a monochrome icon, and your icon then can adapt to the wallpaper and make a nicer UX for the user. All right, so here's a quick summary of a lot of other changes based on if it's affecting your app regardless of your target SDK, or if it only affects whenever you change your target SDK on your application. So they are values. But don't worry, if you want to know more, you can go to this link and you will find all the new things on it. And then you can be prepared whenever the user that in a few months they start adopting Android 13. All right, let's switch now to Jetpack Compose. So as you know, it's a new framework to build UI and a new kind of paradigm on how we're going to build UIs on Android. It's already on stable version, and we are working on the version 1.2 already. And here I'm going to cover like some of the changes that we're introducing. We are introducing the downloadable fonts. So this is something you could already do on the traditional Android views. You could use the font manager to download new fonts and display them in your views, but on Compose, that was an easy way to do this. So we are integrating those two APIs, so you can easily do that now in Compose. And as well, the font will dynamically adapt to the screen density and so on. As you might know, like nobody has like a clean slate sometimes to have a project that's built on Compose. So we're going to be here for a while where we have going to have views and we're going to have Compose code, and they need to work together. And they do in most of the cases. But for example, there are certain views, especially on the scrollable, that they do not work together nicely whenever you mix Compose parts and traditional views. So we introduced a new nested scrolling interop where certain components will work much nicer together. We as well introduced a new lazy layout that will enable grids, will enable custom implementations of your lazy layouts, and you can create different type of scrolling behaviors that will work nicely. We are bringing the Windows Inset. This is an API that was part of an external library called Companies. And we are bringing to the core foundation of Compose, basically that allows you to automatically get the paddings and margins to your screen based on the device characteristics. For example, if it has like a navigation bar or not, if it has a notch on the top and so on, it will automatically patch your UI, so you don't have to manually do it by yourself. Another interesting API, and this is a work in progress, but it's coming soon, it's the shared element transition. Traditional views had already this sort of API where you could share elements of your view with the next fragment, for example, so there will be massive transitions. So now that you can as well do the Compose, now is still experimental, but it will be soon available for we did some changes as well on the tooling. So Android Studio, we want to adapt it as well to be Compose friendly. And one of the nice things they introduced recently is the live edit. So basically, you can preview your composable UIs, and then you can change some of the attributes, and it will automatically render on the preview view without having to compile and wait and so on. So that will allow for faster iterations. A really great tool is the Recomposition Debugging that is introduced recently as well. And as maybe you're not familiar with Compose, but basically it works on a different paradigm. And whenever some data changes, your full UI might recompose, means that it renders again. Sometimes it's difficult to track why is that happening, which parts are happening, and how. So the Recomposition Debugging will be able to track and backtrack what is changing and why it changes. So allows you to improve your performance on the UI. We really betting on Compose, so we are bringing Compose to other platforms. Jetpack Compose is now available for Wear OS, and it simplifies development for Wear apps as well. It as well automatically you get out of the box like some material design components with Compose, and it kind of share a lot between the app development Compose. there's like core libraries that they are shared together, but as well there are some new components that they are only available for web, like like circles and different type of behaviors on the watch. It's now in beta, so you want to try, you can go to this link, and then there are like new documents and code labs and so on. And finally, there is as well a new framework that's currently in alpha that is called Glance, that is to bring compose style code to other glanceable areas on Android. What are these glanceable areas? This is some information that they provide quick and access view for applications. For example, the widgets on your home screen. So you can now use some sort of compose style to create widgets and make the development of widgets faster. It works a bit different than the traditional compose. So basically, the framework builds on top of what is called compose runtime, that it acts as a translator. So you can use compose code style, and it's easy and abstract for you, and it internally actually translates into the actual system components. That is the remote views and XML files for widgets, or for the case of where tiles, it translates into some specific language for the where. You can try it out already in alpha, but it's an ongoing development. And that's all I have to share.